Welcome back, grade 12. Uh, this lesson is topic number 7, and then it's chemistry part of physical science. So we'll be talking about chemical equilibrium. Remember, previously we talked about the rate of reactions. Now this is a continuation, and then now these are the important terms that you need to know. So let us then now revise the terms. Then now the open system. What do we mean when we talk about the open system? Open system simply means now the system is able to interact with the external environment. That is, the matter can leave and enter the system, and the energy can also be exchanged between the system and the environment. So that is the open system. Now let us have an example. Suppose now we have a container, let's say it's a beaker. Then now we supplied with heat. That's supplied with heat. Then now what happens? Suppose now we have the contents here. We have the contents here. And now the contents are reacting with one another. And then when you supply heat, obviously now the particles gain energy. And therefore now they can collide. Remember, we did collision theory. And then in the form of boiling, they can escape and leave the container. At the same time, suppose therefore now remember we also have the gas particles. Yeah, they may enter the system. Suppose now when you were filling this container, it was cold, but after a certain spontaneous reaction, then you fill it. Then now it is hot, which means therefore now the system's energy can be transferred from the system to the environment. That is the open system. Now let us then now check. We also have the closed system. If the system is closed, then now we are saying no matter can leave or enter the system, but energy can be exchanged. You see that? Energy can be exchanged. Now this is the same as having the container. Then we have the contents, but now the container is sealed. The container is sealed. Then now you touch it, you feel it's cold, and then now you add the contents spontaneously react. Then now you feel it again. Now it's hot. How do you feel that it is hot? Because you are not part of the system. It is because now the system is closed, but the energy can be exchanged. So now I hope we have an idea. Now, how is it different then now? The closed system, how is it different from the isolated system? Isolated system means no matter can enter or can be exchanged. Also, no energy, very important now. No energy can be exchanged. No energy can be exchanged between the system and the environment. So that is an isolated system. Then now we talk about the reversible reactions. The reversible reactions, what do you mean say the reactions are reversible? Then now reversible reactions, we are saying now products can be converted back to reactants. So here should be reactants. should be reactants. Reactants. Products can be converted back to reactants. Then we'll see that the reaction is reversible, and the process is simultaneous. Then in this topic again, we are going to talk more about the word like dynamic equilibrium. Then what exactly is the dynamic equilibrium? The word dynamic simply means a constant change. Dynamic has to do with a constant change. There is a change. Change that is what? That is constant. That is what you mean about the dynamic, the word dynamic. Now, dynamic equilibrium, therefore, simply means therefore the state of balance between continuing processes. Now, there are processes that are continuously taking place, but now look up, all those processes are balanced, which means they are constant, meaning the total number of the reactants making up the products is the same as the total number of the products making up the reactants, keeping the number of the particles the same, number of the products the same, number of the reactants the same. So let us talk about the reversible reaction. Reversible reaction, which means therefore, by the moment the products are being formed, the reactants are also being formed. Sometimes that change is dynamic. That change is constant. Therefore, now leading us to what we call now the chemical equilibrium. Chemical equilibrium, we are saying now it is dynamic. We know now what do we mean by dynamic. Chemical equilibrium, it is dynamic, which means it is constant, meaning the rate of forward reaction equals the rate of the reverse reaction. What does this mean? The rate of forward reaction equals the rate of reverse reaction. Let us demonstrate. Now, when we demonstrate here, suppose now we have two reactants. Suppose we have A plus B now reacting to form B, C plus D. But then now, because they were forming, and then let's say after some time, then now, the B plus C also react to form A plus B. This type of reactions we are saying they are reversible. Now we represent this with these two arrows here. This one for forward reaction, this one for the reverse reaction. Now we have the forward reaction, we have the reverse reaction. Now this reaction is reversible. Now, what do you mean when you say now it is dynamic? Suppose then now we have this container here. Let us make an example of what? Of what is called the phase equilibrium. Phase equilibrium. Now, phase equilibrium, suppose now you have water in here. You have water in your form of a liquid. Then now you supply heat here. Then now you seal the container. Then now what happens? What are you going to see? You're going to see the water is after some time is going to evaporate. Then after evaporating, while it is still evaporating, then you are going to see you're going to see the gas here. It is going to be cloudy. The container, the upper part of the container is going to be cloudy, which means it shows that the water is evaporating. Suppose now, during the evaporation, you have 5 particles of water. And then now, remaining particles here, you have 10 particles of water. Which means the total particles of water, you have 15 particles of water. Now, and then after having these 5 particles of water, then now, you see this water remains the same. This is water, which means we are going to measure this volume here. This level remains the same, but you see the water is boiling. What exactly is happening here? Simply means, therefore, now, these particles are moving up, and then now, at the same time, you are going to see the drops of water. Then the water is dropping, the water is dropping, which means at the same time, now the other particles are condensing. But then now, if you are having two or maybe let's say one particle moving up, at the same time you have one particle going down. You have one particle moving up, at the same time you have one particle going down, which means therefore now the total number of particles here is going to remain 5. Total number is going to remain 10. So which means a process is dynamic, because now it is constant. There is a change, but this change is constant. Now it makes sense. I can see you smiling. Thank you very much. It does not mean chemical equilibrium or dynamic equilibrium does not mean we have the same amount of gas and the same amount of liquid. No, it simply means the number of particles that are being transferred from this to that phase is the same as the number of particles that are being transferred from this phase to that phase, leading to this now particles remaining constant. Now this is called now the phase equilibrium.